Our next presentation is by Shelly Uhlir, exhibit specialist and Mountmaker from the Smithsonian, the National Museum of the American Indian, and Jim Williams, senior exhibition designer, preparator at the Kent State University Museum, and Adam Bradshaw, design fabrication consultant, Miras Museum Solutions in Michigan. It's a provocative title. I think you win the ribbon for that. Gridding Our Loins, Exploring Interlocking Mannequin Structures 3 Ways.
Thank you so much for your kind introduction and for having us here at the International Mountmakers Forum. Today, Adam, Jim, and I are here to share our ongoing collaboration around what we are calling Gridding Our Loins, which is an exploration with interlocking, flat packable mannequin cores and structures. In museum mannequin fabrication, whether you create custom mannequins or adapt existing forms, the challenges of customization, minimizing plastics use, managing storage space, and using time and materials efficiently are all daily puzzles for us to solve. A few years ago, with these challenges in mind, I started a casual quest to try to find useful, practical options for making custom museum-quality mannequins that dealt with some of this. Starting from the existing menu of approved mount-making materials, I kept landing on paperboard as a starting exploration point. It's strong, lightweight, recyclable, inexpensive, and it can be archival. The question was if it could be strong enough to carry the weight of heavy garments and customizable enough to be practical for our uses. As I began my research, there seemed to be a lot of fun paperboard designs in the merchandising, fashion, and robot worlds. While these concepts weren't focused on the archival materials, customizability, and support needed for our collections, they did seem to offer a lot of potential. As always, finding time to explore these ideas more fully was hard to come by, until the pandemic and a puzzle offered me the time and inspiration needed to begin to follow the path a little further. To me, the torso structure of the little bear in particular seemed to show some potential in terms of garment support. So when I found myself at home with some extra time on my hands, I played around with making my own version of this interlocking style of torso. I used my normal templating and patterning techniques to measure the piece. Then, using just archival D-board, a mat knife, and math, I began to play. I created flat panels to accommodate only 2 planes, the vertical front to back plane and the horizontal circumferences of the bust line, the waist, the hips. These 2 planes aligned with what I saw as the most important support measurements on a custom form, which define the posture or the historical silhouette, and then in the horizontal plane, the bust, waist, and hips. I did not attempt to add the vertical left to right elements in this case because I figured that the center pole would stabilize the structure and keep it from collapsing. While the basic structure was stable and promising, you can clearly see that there were issues with support along the lines of the shoulder, up in here, and where it's kind of going a little concave in that area. Because the shoulder structure is crucial to the safe support and proper hang of any garment, for this idea to be useful at all, this challenge would have to be resolved. Also, while I was satisfied that this work could be done by hand, it was laborious to do it that way. I've been looking for a project to explore some of the higher tech methods available because I know next to nothing about them. So this seemed like a good opportunity to learn. But where to begin with this? I first discussed this with Craig Husway in NMAI's exhibits department, where he runs our CNC router. And he said he was willing to help cut the materials for me if I got him the files. Now I just needed to learn how to get the files. Then Jim Williams and I were having a conversation about mannequin making one day, as you do. And when I brought up this idea, he immediately saw possibilities for the types of historical and fashion mannequin silhouettes that he works with the most. Jim also has access to a laser cutter and other equipment at the makerspace at Kent State. Then Adam Bradshaw came to mind when I realized that I could use a lot of extra help understanding the technical possibilities. He brings amazing skill, knowledge, and problem solving from his experience with mounting the astronaut suits at the National Air and Space Museum, among other things. He's done thorough research into affordable software and practical tools, and he has the rare ability to describe complex systems in accessible language. I also love that the three of us come from very different institutional collections, display aesthetics, and technical experience, and that we each bring different complementary skill sets and points of view to the table. We decided to take this exploration in three different directions that suited our varied skills and needs. First of all, we wanted to use computer modeling to pare the original design down to only its most necessary elements and to a size that would work for almost any sized human form, then fabricate it using CNC tools in a variety of common materials to test strength and price options and practicality overall. The advantages of this approach would be that one could have these standard cores on hand and simply insert reusable Ethafoam pieces to potentially speed up the mannequin making process, cut down on the amount of Ethafoam needed, and create a reusable and flat packable system. Adam took on the bulk of the development of this aspect of the project. The second step of the research was to take the process back to a low-tech, hands-on approach. Recognizing that many mount makers are in a situation where access to the computer programs, CNC router, or laser cutter is not available, we wanted to see if the method could still be practical. Once we had the core designed and an existing pattern to work from, we took a step back from the technology and used those to cut the pieces by hand from archival D-board. I explored this aspect of the experiment. And finally, we wanted to fully challenge the technical aspects of this idea with a practical challenge. Could these ideas make it easier to fabricate a custom form for a specific historical silhouette? Jim took on this part of the project. The idea of the Mannequin Core evolved from my initial experiments and dissatisfaction with the shoulders. I wanted to find a way to hone the interlock portion of a form down to its most elemental construction. The idea was that the shoulders, as well as the other support areas, could be made of reusable Ethafoam pieces, requiring much less foam than a full Ethafoam form would require. The goal was to make the core lightweight, inexpensive, collapsible, and reusable, and of materials that we can use in museum situations.
So I've got a screen recording here that sort of describes the starting point of the collaboration between Shelly and I, and how we wound up getting to the mannequin system, or the interlocking panels of the mannequin system. So to begin with, we began by using Make Human. And if you're not familiar with Make Human, it's a really cool software program. It's completely free. I'm not going to go into it too much detail here. Jim's going to talk a little bit more about it later on in the presentation. But basically, it's a modeling software that allows you to take a generic human form, human shape, and really customize and tailor the specific elements to whatever your needs are. It has all kinds of different presets, has all different kinds of manipulation tools, all these cool little poses that are sort of built into the program itself. So you can really do a lot with this program. But for our needs, we really just needed a generic form. We needed a generic human form to be able to work with. And so once we had our model set, we then moved over into, this is a program called Fusion 360. It is not free, but it is very affordable for a CAD software program and for all the cool stuff you can do with it. We started sketching out the basic shapes of our interlocking panels. One of the things that Shelly and I talked about initially is that we needed this to be lightweight, but we also needed for the panels to lock together in a way that was going to be very secure and very strong. So we developed this cross-lapped slot system here, and that helped make the core panels, the four that sort of make up the two sides, the front and the back, That made the whole system very, very rigid and really strong, and allowed us to have the ability to attach different parts to the front and back. So depending on what your needs are specific to your mannequin, you can include or exclude whatever elements don't fully match up with your shape. So we also made it so that it could sit on an existing mannequin pole. And we're working here with a male figure, but we also made it so that you could utilize this with a female form as well. So. Once we had our shape, the next phase was to bring it into Adobe Illustrator, where we laid everything out and created line drawings of the different parts. Our main focus here was to lay everything out in a way that made it as accessible as possible. So depending on what your process of fabrication was going to be, we wanted to make it so that if all you had was a printer, you could print these out as a paper template and use that to create your forms. If you had something like a laser cutter, the same file could be used as a laser cutting system. And in our case, we knew we were using it for a CNC router. So we made everything laid out for our sheet stock to be able to be machined on the CNC router.
So once we had the files the way that we wanted them, we needed to try out a prototype. Adam translated his work to DXF files and sent them to Craig, who laid out the pieces for maximum efficiency for his CNC router. In the first round, he cut out the pieces for the forms from Black Comacell Plus, and you see the remainder in the picture on the right. So you kind of see the cutout blueprint. This wasn't our ideal material since it's heavyish and it's still plastic, but that's what he had on hand while we were awaiting our other materials, so the price was right to get the ball rolling. Craig chose to not cut the holes and lettering that Adam had in the original drawings due to time constraints. Since the separate cut pieces weren't labeled, I was concerned at first that it might be too tricky to figure out how to assemble the various pieces into the form, but it turned out to be no big deal at all. Craig supplied me with his layout sheet that had the labels on it, and since each piece is unique, assembly was actually very easy. This also brings up the practical point of how much time is needed for the router to do its work. Each machine will be slightly different in that regard, but in general, more complexity will, of course, equal more time for the machine. That can be an important consideration in a busy shop for cost as well as time concerns. In the end, Craig reported that it took about 20 minutes for him to set up and cut this first batch, which was for one Mannequin Core. So obviously, Craig is experienced at this, so the setup time would be pretty quick. And if you were doing multiple cuts, then that would end up saving time in the end. But just for a one-off, 20 minutes was what it took. Once we had a prototype core to play with, I wanted to see how much I could minimize Ethafoam use while still supporting the shoulders fully. I also wanted to see if this process actually saved any time in fabrication. These images show the first steps to that goal, working out the fitting to the core structure so it could be removable and reusable. As you can see, I solved for the shoulders with traditional Ethafoam methods, but I used much less material and was able to pull it together from my scrap foam bin. The shoulder section slides into the core at the top and is kind of held in place by that grid structure, and it's removable because I didn't glue it in place for this experiment, or screw it in place. You could do that also. You can also see that there's one ring of chest circumference inserted also. The spacing on the core for this set is for 2-inch Ethafoam, but I could have removed a row of horizontal elements to allow for 4-inch foam as well. This standardization offers an opportunity to create a system of foam inserts at specific diameters that can be reused. I didn't spend a lot of time fussing with carving details on this one since we were just testing the system, and this isn't an actual collections item. But I will say that even though this was the first time working through the process, it took me about a third less time getting to this point than carving a regular full torso, so 2/3 the time. As a result of the first trials, we did make a couple of adjustments to the core the files in the for the core, like knocking off some corners and some other small tweaks. Adam then made a set of files for 3mm material so we could try an 1/8" die bond version as well. I wanted to try this material for its rigidity and durability, plus it's slightly less heavy than the coma cell. Die bond is aluminum with a polyethylene core, so I don't know if it actually lessens the plastics use, but we're adding aluminum. I estimate that for each core, it cost about $35 in material. On the left, you see a die bond version before assembly. It was structurally stable with only a few of the horizontal elements in place due to the kind of cube that's created when the four vertical pieces come together. And in the middle, that locks into, it creates a kind of a hollow cube in the center of the form. The nesting tabs in the horizontal levels also obviously add to the stability. I found that once I had the front and back and left and right elements connected, I only needed 2 sets of horizontal levels at whatever level to lock it in place. Normally, I tended to take out the very top level in order to accommodate for the shoulders. So I used the second level down, and then the bottom level was the minimum that I could get away with. Finally, we did a version using 6mm coroplast since it's extremely lightweight and inexpensive. And yes, it is still plastic, but I wanted to see how well it held up and if the sharp edges, from the coroplast might be too troublesome to work with. I was able to use the same shoulder inserts on all 3 of the versions, which was also nice. As expected, the coroplast was super lightweight and cheap. Each core cost about $10 in materials, and it was also very strong. And it might not hold up as long as the die bond version would, but I think it would hold up for a while. In this picture, you see all 4 generations, including the initial home cutout version. They all, except for the home cutout version, worked great, and none of them collapsed when I performed my very unscientific tests of kind of like hanging on the shoulders once I had them in place a little bit. So I don't know exactly the poundage, but they didn't even start to think about collapsing. A note that because I wanted to maintain the reusability component of the cores, I didn't glue or screw anything into place, and which would easily be done through any of those foam layers. And even without that, it still all held together beautifully. It wouldn't take much to make it even more solid if connection was desired. So I don't always have access to a CNC router. So the core design isn't fully useful to me unless I'd be able to make it myself using regular shop tools. I also wanted to see if this method was practical in mounting an actual collections garment. Fortuitously, I had just made a traditional Ethafoam form for the Seneca jacket, so the timing and templating was all pretty fresh in my mind. This jacket required a very simple form, so it also wouldn't add much level of difficulty, complexity to this experiment. I knew that the original form had taken me about 4 hours for the carving, so if the interlock core saved time in fabrication, that would be great. First of all, I exported the 6mm version of Adam's file to PDF, or maybe Adam did that for me. He might have done that for me. And then I printed out a tiled version of that PDF onto normal 8.5 by 11 paper. I taped the tiles together and pieced them onto my D board, which I think some people call B board. You can see in the picture, it's like a double layer of archival board. I decided to go super low tech and just use my mat knife to cut out the pieces since I knew the paperboard would kill my bandsaw blades. If we were using die bond or some other easily cut material, I could have used my bandsaw and saved even more time. But to save my hands in this case, I cut out the minimum number of pieces needed to maintain structure for this material, or that I thought. You see on the right, the finished core with only 3 horizontal levels. It took me about an hour and a half to cut all these pieces out, maybe a little less, I don't know, about an hour and a half, and 5 minutes to assemble. They aren't as pretty as the CNC cut pieces, but still fit together really well. In fact, The imperfections made the pieces lock together, even though there's a little more grab, and so they didn't come apart easily. And remember, now I can use these again. Obviously not as many times as the Coroplast or the dye bond, but they are reusable to some point, I think. We'll have to experiment to see how long how many times we can use them before they fall apart. So here on the left, you see images from the Ethafoam cutting process. It took about an hour to cut the foam pieces and carve the shoulders. Some of this time was working out the cutout templates, and since these pieces can be reused, the fabrication time will only get shorter. I had originally planned to make the form fill in all the kind of gaps with Ethafoam pieces, but after I had the shoulder and hips in place, I decided to make a Fosshape skin for this form, since the garment was so lightweight and I had the existing Ethafoam form to model from. There's a lot of info out there on the Fosshape process, so I'm not going to go into that here. But the torso in process is shown on the right. I'm not actually even sure that Fosshape was necessary for this one, but it did smooth all the joints over nicely. I think the same effect could have been achieved with a layer of batting over the Ethafoam and then stockinette or some other, covering that you normally use. I think that for more lightweight garments, it might even be possible to minimize the foam use even more by using the same core structure to support a Fosshape or buckram skin with only an internal neck support, but I haven't had a chance to play with those extremes yet. There are so many possibilities for variation on this process, and I hope that some of you will continue the experiment. So here's a comparison of the original Ethafoam form and the Fosshape skinned low-tech form. Can you tell which is which? They both need a bit more support in the hip area, but besides that, they're pretty close. And both offer good support for the shoulders, chest, and neck. The low-tech version is on the right. Both forms use the same Fosshape arms, so the arms are kind of a red herring there. The foam form on the left took about 4 hours for fabrication, as I'd said before, and the low-tech form took about 3 hours, including the Fosshape. So that time could be cut down even less. The low-tech version is much lighter, but it's also less sturdy than the foam, obviously, in the center. So if you were making something that was needing to ship or be handled more, you probably wouldn't want to just do the Fosshape or use a heavier Fosshape. All in all, I feel that this could be a useful option when access to a CNC router is not available. It allowed me to use smaller pieces of Ethafoam, and I'll be able to reuse the core, the shoulder insert, and the horizontal cutouts. As a low-tech option, I feel it was a success. But now let's hear more about the experiments that Jim did that took the process in a different and also very promising direction.
Okay. After talking with Shelly about ideas for mannequin fabrication, I chose the high-tech route of using software and CNC tech to custom fit a form to a garment. Historical physiques and silhouettes change over time, and capturing the size or posture using off-the-rack mannequins and forms can be challenging. This is an attempt to achieve a very custom fit while also creating a form that is both archival and green in that it uses less foam than a typical stack laminated form. As you can see in the photos, even our best historical mannequin, the Kyoto mannequins developed by the Kyoto Costume Institute and the Met, can't always capture the nuance of the silhouette. Plus, they cannot be made smaller in any practical way, and padding them out can be challenging. So careful measurement of an historic garment will gather information needed to create the proper form. And Shelly showed you the kind of template that she uses, which is pretty typical. So conservators and curators will carefully get critical dimensions, including spine length, waist, bust, hips, distances between nape to waist, waist to hip, etc., to try and get the form as close as possible to fit the garment without stress and supporting it where needed. Make Human, as Adam showed you, is a free program and it's used to create figures for 3D modeling and video gaming. It has a limited range of possible dimensions for the figure, but it can be a solid starting point for making the wireframe necessary to create the slotted grid that we're after. So here's a short video of Make Human in action. You can see I'm positioning the mannequin to try and create this mid to late 19th century S-curve silhouette. There are limitations to what you can generate on this platform, and there are likely better programs out there, but for experimentation, this worked pretty well, and the price was right. I'm simply manipulating the sliders over here to change the form, but you can actually enter exact measurements in to the program. Now the model from Make Human is imported into SketchUp, which is the program I'm most familiar with and comfortable with using. And that's for the process of turning the STL file into a wireframe and making it into a manifold solid that you can modify into a grid. I amputate where necessary and fill the voids to achieve a solid component, as the gridding plugin won't work if there are any voids left. I'm planning to explore this process in other programs such as Rhinoceros, but SketchUp is what I'm comfortable with. When we get on our GitHub site, we'll maybe do some upgrades and you can add to our files and show us your experiments too. Now that I have the form edited and have checked to ensure that it is a manifold solid, I can use the Slicer 5 plugin with SketchUp to create the grid. The software allows me to set the spacing on 3 axes, or I'm only using 2 actually, the X and Z axes, and the material thickness to work with whatever I want to use. So I've set the thickness to just below 1/8 because the B-flute corrugated is 3 millimeters, and so is Dearborn, which is convenient. Since I plan to fill some of the voids with Ethafoam, I set the parameters for 2 1/8 inch for the horizontal spacing, which is the thickness of the foam I had on hand. I set the vertical center line to gap, which allows the insertion of the pole in the center to work with my existing stand. Then I let the program work its magic. As you can see, it produces both a constructed grid and the flat patterns I will need to edit in the next step. So in SketchUp, the elements have their thickness, and you need to remove that in before you take it into Illustrator. So I've gone into SketchUp here and gotten rid of the second layer of the material, and I have to get rid of all these little vertical lines, which are just going to be points that will confuse the laser cutter later. So be sure when you export that you've got it in camera standard view top, so you're not exporting a foreshortened image, because it would cut them foreshortened just like that. I also moved the layer IDs onto each pattern piece so that the cutter would etch them in, making assembly that much easier. Once the form's been edited to a single layer in SketchUp, it's exported as a DXF file and taken into Illustrator for final editing and to ready it for cutting. You select the outline only and use the paths join command to make the faceted outline into a single vector file. You can then use the smooth tool to reduce the number of data points and anchors. Use the pen tool to tweak and modify the curves as you see fit. And then you'll assign appropriate colors for through cuts versus etching. In this case, through cuts are red and etching is blue. So you can see here, I'm just dragging along the lines to try and just simplify them a little bit and make it easier for the laser cutter to not have to work with so many data points, which speeds up the cutting process too. So between Make Human, SketchUp, and Illustrator work, I spent approximately 2 to 3 hours creating this file. That includes a learning curve, so it's actually pretty efficient. I'm sure as I learn better skills in all the software or get better software, this time can be reduced. So here's the file ready to cut. Once the paths are cleaned up, the colors are assigned to indicate through or etching cuts, the model's ready to go under the knife. Nest the parts as closely as possible to minimize material use. For water jet and CNC routers, you may need to add tabs to hold cutouts in place and eliminate them later. After the knife, here are some views of the finished form in archival Blueboard. I also did a trial cutting with dye bond and a water jet, but it proved to not be worth the expense. I wasn't happy with the weight and the sharpness of the cut edges or the cost. The archival board is quite strong once the foam is glued into place, though the gluing does eliminate the ability to flat pack and store the form that I had hoped to achieve. Once I had my gridded loins, it was time to flesh it out with foam and batting. The lines created by the board give the sculptor great guidance in how to shape the foam, which would allow even a novice to get a smooth, accurate form. By keeping the foam only to critical areas for garment support or important contours, I reduced the amount of foam I'd typically have used by 2/3 or more. A base stockinette skin helps to hold batting in place while the top cover is being stretched over. Again, by getting such an accurate base, the use of batting is minimized, and overall I'm happy with how green this process can be. The finished form is in the upper right here. There is a lot of potential to this process, including making much more gestural poses, creating forms that are more accurate to varying body types and silhouettes, and creating clone armies of figures if I'm doing an exhibition of a specific individual. Material costs were pretty minimal since I was able to use Ethafoam drops from other projects and half a sheet of B-flute board. Like Shelly showed, this could also be accomplished by printing the patterns and hand cutting the board, but it sure was nice to let the laser do the work for me.
So while this research is ongoing and far from over, we have created a GitHub repository where all the different files that were used and shown here today can be found. Feel free to download them, use them, change them, share your changes, and re-upload them back to this repository. Here's everybody's contact information if you need to get a hold of us. And a special thank you to everybody that was involved in helping create this project. Really couldn't have done it without you. Shelly, Jim?
Everybody.
Thank you.
Thank you. If you have any questions, we'll talk later.
All right.
Are there blinds going? I'm hearing.
Somebody got an amber alert going?
Thank you so much for that talk. I love the collaboration. How did that, it's Elizabeth back
hi.
here. Sorry, Shelly. How did the collaboration come about?
I'm going to lower the, this goes down. Hi. So the collaboration came about because I was bored during COVID and I was playing with everything myself, you know, like you saw in the thing, that I was doing it by hand, and clearly that was going to take a million years. It wasn't practical to use that. And I just thought of these guys because for the reasons that I said in the talk, you know, that Jim has vast knowledge of mannequins and is also interested in the technological side, and Adam has a vast knowledge of the technology and mannequins. So, yeah, it just came about naturally through conversations.
Would you mind bringing up the GitHub slide? Is that possible?
No, because ours isn't a PowerPoint.
Oh, right, you're right. It's an MP4.
Yeah.
I can distribute that. I can email it to people because I think a lot of people are interested in the GitHub site.
Absolutely.
I can take a
yeah.
screenshot and send it, unless you can take a screenshot, because I think, Adam, your name, your picture is over the title of the site.
Okay.
So if you wouldn't mind sending it to us, and we can send it to the
Absolutely.
attendees.
Yeah, our, oh, yeah, that's right.
We're going to get an apple crate for Shelly.
Bear with me.
Oh, we have a question, a virtual question. Since I have the mic, is it B as in boy, board, or is it D as in dog, board?
Single flute is B flute, and double flute is D flute. Double corrugation layers.
Thank you.
I have a question for the CNC. I've never cut or thought to cut blue board or D board on the table. What were your feeds and speeds for that, or is that in the online document and information?
Well, I know that Shelly utilized Craig Hawsey's
skill on doing that. Typically with coma cell and die bond, you're going to be using very specialized machining tools for that. Probably not going much more than about 50 millimeters a minute or so. There is probably some adjustment depending on what kind of machine you have. So.
Thank you.
Also, can I just do this? I just wanted to clarify that we didn't, for the pieces that I worked on that had the D board, we didn't do that on the CNC router. We just did the die bond and the coroplast and the coma cell on the CNC router.
Oh, thank you.
Mm-hmm.
My question is for Shelly and perhaps Jim as well. When cutting the D board or B board, from your design in Illustrator or SketchUp, did you create a template to then put over the blue board to use to cut out the elements of the core?
For me, the archival corrugated was cut on a laser cutter. So I just laid it in a machine, pressed a button, presto changeo, it cut it pretty quick. I think the cutting time on that was less than 20 minutes. And yeah, for Shelly, she used hers just by hand from the drawings. Yeah.
I mean, I'd recommend if you have access to a laser cutter, do it that way. Because, I had a pretty sore wrist at the end of it. But if you don't, we just wanted to make sure that we explored, not everybody has that. I don't have a laser cutter, So if this core idea was useful, it had to be something that I could make in my shop, without needing those other tools.
So are there any concerns with the board doing it in a laser cutter with anything being reactive after it's been cut?
I can't imagine why. It's a very light toast on the edge, so I can't imagine that it's really changed the chemical composition of the board or anything, but it probably would be wise to do a cutting and do an Audi test on it just to make sure. I don't have that kind of a facility, so I'm just trusting my gut on that one.
If I could jump in on that, there's also some acid neutralizing sprays that you can use post-processing for laser to help encapsulate and neutralize anything in addition to removing any soot that builds up on the edges. So.
Shelly, you mentioned you were hesitant to use your bandsaw on some of the board that was being experimented with. Can you talk a little bit more about that?
Yeah, so I just find thank you. I find when I try to put any kind of paperboard product through my bandsaw, that it tears up the blades pretty badly. So I would use the bandsaw for the die bond. I'd use it for the coma cell. I'd use it for maybe the coroplast, maybe too. But the coroplast I can cut pretty easily. But I've just had bad experience with the bandsaw blades and the paperboard. I don't know if other people found a way around that or use a different blade or something like that. I'd be interested to know.
I have a question for Shelly. I love the way that you do your shoulders on your mannequins. Is that, are you using the Fosshape? And if so, is it just a friction fit when it goes on the mannequin, or is it a fastener of some kind?
So the starting point for the shoulders was Ethafoam, and you wouldn't have to use Fosshape over it. That was just part of my kind of brain spinning out into other variations, right? The way that it fit, it just kind of friction fit. I cut it so it could friction fit into that grid work, that was formed in the top, and then gravity kind of holds it. Again, though, we were doing this as an experiment, and if say the mannequin that I made was for travel or something like that, it needed to be a little more sturdy. I just probably put a couple screws through it and connect it. I mean, I try to actually minimize my hot glue use too. So, you know, I would probably do something mechanical like that to hold it in place. And also, like, if I were going to be adding arms, we had a whole, like, we're going down this rabbit hole of arms, and, you know, all the things you can do with mannequins. If you were starting to add some of that internal structure, then that would also kind of, maybe it could be incorporated and hold everything in place even better, right? Yeah. Did I answer your question?
Yes, you did.
Okay.
Thank you.
If you get me started talking about this, I'll just keep talking.
There's a virtual question from Earl Luck. He said, what about cutting the bracing out of 1/2-inch thick 9-pound Ethafoam?
Yeah, absolutely. I mean, you know, in the way back, Denis LaRoche, you know, did those Ethafoam mannequins that were interlocking Ethafoam. You know, he did that a long time ago, you know, with, you know, cutting silhouettes and stuff. So definitely, you know, this could be just taken to that. Part of my initial set of ideas was I'm trying to minimize plastics use. I'm trying to minimize Ethafoam use. You know, that's all that stuff besides, you know, the planet-related things that's getting more and more expensive, or in addition to the planet-related things. And so we were trying to minimize that Ethafoam use. So that's why we're trying to kind of find some other materials that could bring in the same stability. And it was only when I had that kind of struggle with the shoulders that I think Jim actually solved really well with his, by filling in all the gaps and smoothing out things there. That resolves that too. I just ended up going down this other path with, like, well, for making interchangeable things, I could see having, you know, like a set of different shoulders that, because they're Ethafoam, you can recarve them, or, you know, you can adjust those and then just have them fit in place. Yeah, but that's a great idea, Earl. Thank you.